Welcome to the lecture. Today we will see the topics related to the slicing, dicing and the concatenation of the data sets. So what is slicing and dicing? Slicing and dicing means the filtering and selecting the data. It might happen that you may not need to work with all the data in the data set. So in fact, looking at just one particular column might be beneficial, such as the age or a set of rows or the set of columns. So for that you have to perform the two different tasks. That is, the first one is to the filter the rows to create the subject of the data, and the second one is to select the data columns that contain the data that you need to analyze. So you have to select the appropriate rows and you have to select the appropriate columns, and it might happen that you may not need the whole data set for the analysis. So how to extract that particular rows from the data set? So let's start with that. So slicing means to extract either the rows or the columns from the data set, that is the required rows and required columns. So for that we will use data science libraries, that is the NumPy and the Pandas. So starting with the NumPy library first. So I'm importing the NumPy library, that is import NumPy as NP. I have written the NP because I can create the NumPy array by using the name as NP, and to create a one-dimensional array in NumPy, so I will write like this, that is a equals to np dot array. Into the square bracket I have to give one dimension like this, that is, suppose I am giving 1 2 3 like this, and I am printing the value of a. So this is my one dimensional array. So np dot array, that is the square rounded brackets. Into that rounded brackets you have to mention within the square brackets, that is 1 2 3. So this is my one dimensional NumPy array. What is the difference between simple your all the data structures in Python and this NumPy array? The benefit is the NumPy array works faster than the usual regular data structures available in Python. So NumPy is faster than the other data structures. Now I want to create two-dimensional array in NumPy. So I will write like this, that is np dot array into the rounded brackets. For creating the two-dimensional array, you have to mention the two square brackets. So I am writing like this, that is two square brackets. So in Jupyter Notebook, this two square brackets will be closed automatically. So over here, I am writing like this, that is, suppose 5.5, 6.5, 7.5. Suppose this is my first row. Then outside this, I will write another square brackets. Into that, I will write like this, that is, suppose 8.8, 9.5 and 7.5. And I am printing this B. Then see over here, you can see that my two-dimensional array is created. So this is my first row, this is my second row, and there are three columns. So in the first square brackets, you will be having your first row, and each values is separated by commas. Into the second square bracket, you will be having the values of the second row, and both the rows are separated by a comma. So this is my two-dimensional array. Now comes my three-dimensional array in NumPy. So for creating the three-dimensional array into the np.numpy, you have to create three square brackets and then write all the values accordingly. So this is my first row, this is my second row, and this is my third row. All are separated by comma. So let's print this three-dimensional array. So you can see this is my three-dimensional array. This is my first element at index position 0. This whole element is my index position 1, and this element will be at my index position 2. In my first element, again I am having the rows and the columns. So that will be my second dimension, that is the rows, and my columns will be my third dimension. This is my first dimension, that is my first element at index position 0, 1 and 2. Now I want to perform the slicing operation. So the first one is the slicing of rows. So in that I am writing x of 1. So this is my answer. X of 1 means my first dimension in this three-dimensional array is like the whole element of this square bracket. So this whole is at index position 0, this whole is at index position 1, and I have mentioned x of 1. So it is returning me the whole element at index position 1, that is 11, 12, 13, 14, 15, 16 and 17, 18, 19. Now for slicing the columns, what I am writing, that is x colon comma 1. So the first dimension column means I want all these three dimensions, and I am writing comma 1. Comma 1 means from all these three I want only the rows at index position 1. So what will be my answer? That is 4, 5, 6, 14, 15, 16 and 24, 25 and 26. So this is my answer: 4, 5, 6, 14, 15, 16 and 24, 25, 26. Now I want to perform the dicing. Dicing means the combination of rows and columns. So we have just seen how to extract the rows. Now let's see both together. So this is again my same three-dimensional array. Now I am writing x of 1 comma 1. So what it will give? X of 1 comma 1. So let's run this code. X of 1 means my this particular element, and into that I want only the row at index position 1. So it is my 14, 15 and 16. My first row will be at index position 0. This row will be at my index position 1. So it is giving me 14, 15 and 16. If I write 1 comma 2 like this, then it will give me the row at index position 2, that is 17, 18 and 19. Now I am writing x of all. This column means all comma 1 comma 1. So I want all. Into that I want first rows, and from that first rows, what I want the element at the column index 1. So 0, 1. So I get the answer as 5, 15 and 25. So let's run this code. So I am getting the answer as 5, 15 and 25. Now I am writing 1 colon 1. So what it will give? 1 means this particular one. Colon means all the rows I want. And 1 means the column at index position 1. So I will get the answer as 12, 15 and 18. So let's run this code, and I am getting the answer as 12, 15 and 18. Now I want this one, that is x of 1 colon 2 and 1 colon 2. So the first element, excluding the 2, I can say. So 0 and this is 1. So starting with 1, so it will start with 1 up till you want to go 2, but this 2 will be excluded. Remember that we have seen in the operations on the data structures that if you are writing the column, then whatever you have written on the right hand side, that gets excluded. So only 1 will be considered, and I want from that only 1 row. So let's run this code, that is 14, 15 and 16. This row you are getting like this. So based on this, so many MCQs can be formed. Now I have the slicing and dicing using pandas. So let's see the slicing and dicing using pandas, that is by the data frames. So for that I am importing the pandas library. I am reading my data set, that is the loan.csv, and I am printing the data set, that is the first 5 rows. Now from this, for performing the slicing operation using the pandas, you can there is one function, that is the LOC function. So LOC and ILOC, these two functions are used. What is the difference between LOC and ILOC? By using the LOC function, you can mention the labels, that is the column labels. So you can slice by using the column labels. And ILOC means it is the integer based slicing. So I stands for the integer. In that you can slice by using the index position. You can't mention the column names. So over here I am writing my data frame, that is the DF, where my data is stored. So I am writing df.loc, and I want the first one, it means all the rows, and I want only the column labeled education, this one. So let's print this. So I am getting the answer as education as my column, and all the rows, it means all the rows of my education column. So I am getting the answer like this. You can also store this particular variable, this particular answer into some variable, and suppose my variable is f, then you just run this code, then you are getting the no output. So whatever this function is, that is the .loc function, it is returning some value. and that value is stored in my f variable now. So for viewing the output, you have to print the f variable like this. If you are not storing the value, then whatever answer you are getting, you are directly printing it. So whatever answer this LOC function is returning, that will be printed directly. So this is how it is working in Python. Okay, fine. Next one is I want all the rows and I want two columns. That is the education column and this one principal column and this education column. So I will write df.loc and I have all the rows with this education and principal column. Now my ILOC function, that is the integer based slicing, in that I have written that is df.iloc and I have mentioned colon 4. So let's run this code. Then you can see it is giving me the first 4 rows because I have mentioned colon 4 like this. Now I have not mentioned the second dimension. It means it will consider all the rows. By default it will consider like this, that is comma colon means all the rows, and if you are not writing, then it will consider all the columns only. So colon 4, that is first few rows, and this column means all the columns. If you are not writing, it means automatically it will take all the columns. Now I am writing x equals to df.iloc all the rows, and I want only columns from index position 2 to 4 because 5 will be excluded. So what will be my output? Just guess. All the rows I will get, and my column, this is my column at index position 0, at index position 1, this 2, 3 and 4. Till 4 I will get. So this loan status, principal and terms will get in my answer, that is 2, 3 and 4. So let's run this code. See, loan status, principal and terms, this 3 in my output, and I will get all the rows, that is all 18 rows in my output. Now we will see the concatenating and transforming. So to adding new cases and variables, the term is like this, that is new cases means if you want to add new rows into your data frame, and variables means if you want to add new columns into your data frame. So for that I am using the Pandas library and I am creating one data frame. Above I was having the whole data set in terms of data frame. Over here I am creating my own data frame by using the different column labels. So I am writing like this, that is df equals to pd.dataFrame. I want to create a data frame and I am writing 231 1 2 3 and 4 5 6. So you can see this is my first label, that is A. It contains the values like 2 3 1. My B contains values like 1 2 3 and my C contains value like 4 5 6. And this is my index position of the rows, that is 0 1 and 2. So it will come automatically, and these labels that I have mentioned over here. Now this is my second data frame, that is df1, and in that data frame I have 3 labels, that is ABC. In that I have 1 1 values, that is 4 4 and 4, and it is at index position row is at index position 0 because I have only one row. Now I want to add this second data frame, that is df1, into my first data frame. So for that you have to use the append function. So I am writing over here, that is df2 equals to df.append, and into the bracket I am writing df1. So I want to append this df and this df1, and whatever the answer is, that answer I am storing into my new data frame, that is df2, and I am printing this df2 value. So see over here, you can see my first data frame is 136 at last, that is 136 at last, and then my df1 is appended, that is 444. You can see over here. But what the problem is over here, you can see the index position, that is 0 1 and 2 of my first data frame, and this is my index position of my data frame, that is the df1, that is my second data frame. So I want to again reset this index position. So I want the index position like 0 1 2 and 3 like this. So for that what you have to do, you have to write the code like this, that is reset underscore index drop equals to true. It means old values will be dropped and your index position of the rows will get reset like this. So on which data frame I want to perform this operation, that is df2. So I am writing df2 dot reset underscore index, into the bracket I am writing drop equals to true. So whatever answer is, so I am again storing into the df2. It means my df2 will get updated. So you can see the difference over here. This is 0 over here, and over here it is showing as 3. So this is how you can reset it. So now if you want to add, or if you want to append something at end, that is at last row, after this 3 the next row will be at 4. So you can write the function as df.loc, and you can write like this, that is the data frame dot last underscore valid index plus 1 and equals to 1555. Suppose I want to perform on df2, so I will write over here, that is df2, and I will print the value of df2. Then you can see over here it is up to 3. Now my index position 4 is appended, and what is that value? That is 5, 5 and 5. So over here you have to verify that if I am writing 4 times 5 over here, it means 3 columns, and I am adding one fourth column value, that is 4th times 5. Then see, it is giving me the syntax error. So over here for this particular last valid index function, the match is very necessary. Now the next is with the append function. Within this append function, if we are not matching the columns, then see what happens. So I am appending df1 and this dff. Into my dff I am having what values? We will see first this one. I am having the values as 2 columns and 2 rows, and I want to append this with this one, that is df1. So in df1 what I am having? In df1 I am having 3 columns and 1 rows, whereas in dff I am having 2 rows and 2 columns. So this is the mismatch. So let's see what happens in this mismatch. So you can see over here that it is appended successfully, there are no errors, and whatever the value is not there, so that will be considered as the missing value, that is the NaN. So in case of append, if the columns and the rows does not match, then it is not throwing an error. Now adding the new variables means adding the new columns. So I am writing over here, that is df equals to data frame. I have created one data frame. It has the values like this, that is the key and second label as A. Another data frame I am having, and again it is having the values as key and column name as B. Over here the key is also there, but the column name is A. So if you want to join this two particular data frames, so for joining the columns, you have to use the join function, and for joining the rows, you have to use the append function. So if you want to concatenate rows, then append function is used. If you want to do the concatenation in terms of columns, then join function is used. So keep this in mind. So over here, this is my other data frame. Now I want to join this. So I will write df.join, on which I want to perform join, my df. So I'm writing df.join, and as a first argument you have to pass the data frame that you want to join. And over here my data frame name is other. So I'm writing other. This is the last suffix, that is underscore caller and underscore other. So let's see. See over here what happened. This is my key, this is my label A. So my key underscore caller and my key underscore other. So this caller is from the df, that is the k0, k1, k2, k3 up to k5. And this key underscore other means this particular key column is from this other data frame. So I have written over here, that is underscore other. So when there are two columns with the same name, so I have to differentiate like this. I can't give the same name to the two columns. So it is given like this, and you can see that whatever values that are not present, so it is considered as the NaN. Okay, fine. So this is how we can join the columns. Now over here, what I have done, if you want to join using the key columns, then you have to set the key to be the index in both df and the other. So the join data frame will have the index like this. So over here what I have written, that is I want to join by using the index as key, because in both the data frame, that is my this key and this key, both column names are same, values are also same, that is k0, k1 and k2. These are my extra values, but my these values are also present in my first data frame. So now my this is what it looks like, my joint data set. That is on key I am having k0, k1, k2. For k0 I am having values a0, b0. So for k0 I am having values a0 and b0. So my this, according to the key wise, my joining has performed. You can also perform the same joining by using the on on parameters. So you can write df dot join, that is on other. You have to set the key, and you want to perform the joining, that is on key column. So you will get the answer as this. You can see the difference over here. There is no index position of the rows. Over here there is the index position of the rows. So I'm giving you this particular Word document. I am sharing this document on your drive. So keeping it till here, thank you all.